this will be r square minus 1 only, which is equal to 9 ones are 9 twos are, we have 1 by 2. Here you may get confused, I am taking minus ar common. Minus ar, if you take out from this term, only 1 remains and ar square, a and r is already outside, r square remains. As I am taking minus common, minus will be for the first term and here plus it will become. Again, if you are not understanding what you do, you multiply this minus ar with these two terms. Are you getting back the original terms or you check? Minus ar into r square will be minus ar cube, we are getting it. And minus ar into minus 1 will be plus ar. Like that it is. You cancel r square minus 1, r square minus 1, a and a. We have minus 1 by r is equal to 1 by 2. This is nothing but r is equal to minus 2. Common ratio is minus 2 here. R value got. Now getting the value of a. To get the value of a, you substitute in any one of the expression. You substitute in equation 1. Equation 1 implies a I don't know, r value I know, that is minus 2. Minus 2 square minus a, which is equal to 9. This is minus 2 square 4. 4a minus a is equal to 9. 3a is equal to 9. This is nothing but a is equal to 3. We got first term as 3. Then what are the 4 numbers? Therefore, 4 numbers are a, ar square, ar cube. Write all those. A is 3, a into r, 3 into minus 2, 3 into r is minus 2 square, 3 into minus 2 cube, 3, minus 6, 3 into 4 is 12, 3 into minus 8, it is minus 24. Okay. With this, problem number 21 completed. Now we will go to the next question, that is problem number 21 completed now. Problem number 22. One of the important problem it is problem number 22. It says if the pth, qth and rth terms of a GP are A, B and C respectively. Prove that A to the power of Q minus R into B to the power of R minus P into C to the power of P minus Q, which is equal to 1. We have to prove this. First of all, write the given. What is given here? It is given that pth term is A, qth term is B and rth term is C. And these are A and R is already used, hence what I will do, let first term of ZP is equal to, I will use capital A because that small a already they have used, and common ratio is equal to, let me use capital R here because the small r also they have used. To avoid the confusions, I am taking capital A and capital R as the first term and common ratio. It is given that pth term is equal to a. Pth term is equal to a. What is pth term? Pth term is a into r to the power of p minus 1, which is equal to a. Next, let it be as it is. And again they have given you qth term. Qth term is equal to b. What is qth term? Qth term is a into r to the power of q minus 1, which is equal to b. Next they are saying that rth term is c. Rth term is equal to c. What is rth term? A into r to the power of r minus 1, which is equal to c. Now we need to prove this. Okay, take LHS. LHS is equal to a to the power of q minus r into b to the power of r minus p into c to the power of p minus q. What is a? A value they have given you that is pth term, means that is a into r to the power of p minus 1. This whole to the power of q minus r will be there. In place of a we are substituting a into r to the power of p minus 1 into b is a into r to the power of q minus 1 whole to the power of r minus p into dot here, it means that multiplication into, and c is a into r to the power of r minus 1 whole to the power of p minus q will be there. And this coming to first one, a into b whole square is there, means I can write it as a square into b square. So I will write here a square into r to the power of p minus 1 whole to the power of q minus r into same way a to the power of r minus p into r to the power of q minus 1 into r minus p, which is multiplied with a to the power of p minus q into r to the power of r minus 1 to the power of p minus q. Next, this is not a square, sorry, this is a to the power of q minus r. This is a to the power of q minus r. Okay. Next, this any of multiplication is there. All these terms I will write together. A to the power of q minus r into a to the power of r minus p into a to the power of p minus q, which is multiplied with the r to the power of p minus 1 whole to the power of q minus r. It is like a raised to m whole raised to n. A raised to m whole raised to n is nothing but a raised to m into n according to the laws of indices. Okay, I have here r to the power of p minus 1 into q minus r, which is multiplied with r to the power of this second term q minus 1 into r minus p into r to the power of r minus 1 into p minus q. Okay, these a terms I have written together. You see, it is like a raised to m into a raised to n into a raised to p. This can be written as a raised to m plus n plus p. That is nothing but a raised to q minus r plus r minus p plus p minus q. Minus r plus r minus p plus p minus q plus q. I have a raised to 0 into, now r to the power of, I will multiply this. This is p into q, that is pq, p into minus r minus pr minus 1 into q minus q minus 1 into minus r, that is plus r, which is multiplied with r to the power of q into r qr, q into minus pq minus 1 into r minus 1 into minus p, that is plus p into r to the power of r into p, rp, r into minus q minus rq minus 1 into p minus 1 into minus q, that is plus q. Okay, I have here a to the power of 0. Again you observe r to the power of r to the power of r to the power of. It is like a to the power of m into a to the power of n into a to the power of p, that is equal to a to the power of m plus n plus p. Okay, that can be written as r to the power of pq minus pr minus q plus r plus qr minus pq minus r plus p plus rp minus rq minus q plus q. Sorry, minus p plus q. Check all those, are they getting cancels or not? Cancelling out or not? Plus pq minus pq minus pr and plus rp minus q plus q plus r minus r plus qr minus rq plus p minus p. A to the power 0 is 1 into r to the power of 0. R to the power of 0 is also 1. 1 into 1 is 1. So this is the required RHS. With this, problem number 22 completed. Exercise 9.2, problem number 23. If the first and nth term of a GP are A and B, first term is given and nth term is given here. First term is A, nth term is B, and P is the product of n terms. Prove that P square is equal to A into B whole to the power of n is our question here. Istu now torisbeku. First term here already they have used A. First term A, that is directly given. First term is equal to A, and nth term is equal to B, they have given it. What is nth term in our case? In our GP, nth term is A into r to the power of n minus 1. P is product of n terms. Let n terms are n terms ಯಾವ್ಯಾವು ಅಂತ ಹೇಳಿ ನಾವು ಹೇಳಬೇಕಲ್ಲ ಮೊದಲ, ಅದಕ್ಕೆ ನೀವು GP ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ. n terms are A, AR, AR square, so on up to A into r to the power of n minus 1 is the n terms here. Okay. They are saying P is product of n terms. P is equal to product of n terms. What are those n terms? A, AR, AR square, so on, like this they are going to multiply. Last term is A into r to the power of n minus 1. Okay. P is equal to A into A into A. How many times A is getting multiplied? N times it is getting multiplied. That becomes A is to n into I have r into r square into r cube, so on up to r to the power of n minus 1. P is equal to A raised to n into all the bases are same. So r to the power of 1 plus 2 plus 3 so on up to n minus 1. Okay. What we want? We want P square is equal to. P square is equal to we want. Before that, before squaring, let me simplify this one. ಇದನ್ನು ಮೊದಲು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡ್ರೆ ಆಮೇಲೆ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಮಗೆ ಪಿ ಸ್ಕ್ವೇರ್ ಬೇಕಲ್ಲ ಅದಕ್ಕೋಸ್ಕರ. So what is this? 1 plus 2 plus 3. This is it in AP or not? It is in arithmetic progression. Nodri. First difference between first terms 1, next two terms 1 difference 3 in AP. With A is equal to 1 and common difference D is equal to A2 minus A1. That is nothing but 1. Which formula to use here? ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರಿ? ಸಮ್ ಇಸ್ ದರ್. ಇವೆಲ್ಲ ತನಕ ನಾವು ಸಮ್ ತಗೊಳ್ಳೋತೀವಿ. Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay. N also we have to be careful. How many terms are there here? One term, second term, third term, like that. N minus 1 terms are there. N is equal to n minus 1. That one we have to be careful. N minus 1 by 2 into 2a, 2 into 1 plus n is a number of terms. How many terms are there? N minus 1 terms are there. This minus 1 you write as it is. Common difference is 1 multiplied with 1, which is equal to n minus 1 by 2 into 2 plus this is n minus 2. Okay, plus 2 minus 2 get cancels. We have n into n minus 1 by 2 as the sum of 1 plus 2 plus 3 up to n minus 1. Okay. I have P is equal to, now I am substituting there, P is equal to A to the power n into R to the power of n into n minus 1 by 2. Okay. We have to prove that P square is equal to ಅಂತ ಹೇಳಿ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಏನು ಮಾಡ್ಕೊಳ್ರಿ, ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೊಳ್ರಿ ಎರಡು ಕಡೆ. Squaring on both side, I have P square is equal to A raised to n R to the power of n into n minus 1 by 2 whole square. This can be written as A raised to n whole square into R to the power of n into n minus 1 by 2 whole square. This is A to the power of 2 into n, because according to the laws of indices, A raised to m whole raised to n is nothing but A raised to m into n. Here it is R to the power of n into n minus 1 by 2 into 2 get cancels. We have A to the power of 2n into R to the power of n into n minus 1. See, I want AB to the power of n. Whole power n is required for me. Whole for n is required means this can be written as A square to the power of n according to this law of indices. M into n format is m into n ಗತಿ ಐತ್ರಿ, 2 into n ಅಂದ್ರೆ m into n ಗತಿ ಐತಿ. ಅದನ್ನ ನಾನು A to the power m whole to the power n ಅಂತ ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. into R to the power of n minus 1 whole to the power of n I can write. This is again it is like A square into B square. A square into B square is nothing but AB square. According to this law, that law of indices, I can write here A square into R to the power of n minus 1 whole raised to n. This A square, inside that what I want, inside the bracket I want A into B. So if this A you write A square, you write A into R to the power of n minus 1 whole to the power of n. This first A it is required, you keep it as it is. A into R to the power of n minus 1 is nothing but last term of the geometric progression. Last term of the geometric progression, they have mentioned this as B. Okay, put that B. AB whole to the power of n. Left hand side P square. Yes, you can observe here. We have proved P square is equal to AB whole to the power of n. That is about problem number 23 in the exercise 9.3. Now we will go to the problem number 24. Problem number 24 says, show that the ratio of the sum of n terms of a GP, n terms of a geometric progression to the sum of terms from n plus 1th to 2nth term is 1 by R raised to n. Okay. If you look into the problem, it looks like somewhat very bigger problem, but it is too easy. Show that the ratio ಅಂದ್ರೆ ಇಲ್ಲಿ ಅನುಪಾತ, ratio of sum of n terms 2 means divided by sum of the terms from n plus 1 to n plus 1 to 2nth term is 1 by R raised to n. That one we have to show. We have to consider a GP here. Okay. For that, what you do? You choose the first term and common ratio. Let first term is equal to A and common ratio is equal to R. We need to show that sum of n terms divided by sum of the terms from n plus 1th to 2nth term. This is equal to 1 by R. I have to show. I am taking this one here as no space is there for us. Sum of n terms divided by sum of the terms from n plus 1 to 2nth. This should be on the left hand side equal to this one. Sum of n terms means A, AR, AR square, so on up to where? Up to nth term. Nth term is A into R to the power of n minus 1. Next, sum of the terms from n plus 1 to 2nth. What is n plus 1th term? N plus 1th term is A into R to the power of n. What is the second term here? Second term is A into R to the power of 2 minus 1. Means A into R. What is third term? AR square. Here n plus 1th term will be A into R to the power of n. Plus, what will be the next term? N plus 1th term over. Next term will be n plus 2th term. N plus 2th term will be A into R to the power of n plus 2 minus 1. Means A into R to the power of n plus 1 it is. You have to be careful. Next will be n plus 3rd term. N plus 3th term. N plus 3th term is A into R to the power of n plus 3 minus 1. Means n plus 3 minus 1 means n plus 2. It goes like this. What will be the last term? Last term is 2nth term. 2nth term can be written as A into R to the power of 2n minus 1. Now what you do? You take the common here. What are the common we have in the numerator? A is common. Take it out. If you take A common, 1 plus R square plus so on up to R to the power of n minus 1. Whole divided by. And in denominator what is common? In denominator A into R to the power n is common. If we take A into R to the power n common, this will be 1. A into R to the power of n plus 1 can be written as A into R to the power of n into R. A into R to the power of n is outside, R remains here. Next here R square remains. So on. What will be the last term? Last term we left with R to the power of n minus 1. I will explain that once again. That A into R to the power of 2n minus 1. I am taking A into R to the power n common here. A into R to the power of 2n minus 1 is there. No, I can write it as n plus n minus 1. This is nothing but A into R to the power of n into R to the power of n minus 1. This A into R to the power of n is common outside. So, you see here, these terms are getting cancelled. A get cancels, these terms get cancelled. We left with 1 by R to the power of n. Hence, we should that sum of n terms divided by sum of the terms from n plus 1 to nth term as 1 by R to the power of n. Thank you.